a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. I hope that by now seeing these order of operations is a mere formality. They should have been learned a long time ago. We have used them so much, and certainly know these as you move into algebra. Also, if you are developing mathematically, when you look at a string of operations like that, your eyes should not see the numbers first. They should indeed note the operations first, for they, after all, is that which is going to tell us what to do. Then decide, in this case, between these three operations, what one we will do first. And of course we do multiplication and division before addition and subtraction, and we do them as we come to them. So the first thing we're going to do is the division, which is between those two numbers. And in fact, everything else will remain the same, at least in our mind. So we're going to replace this division by its quotient. And of course, 24 divided by 4 is 6. Now again, note the operations. And by the operation, the multiplication is done first, and it is between 6 and negative 2. So when I'm multiplying unlike signs, the answer is negative. 6 times 2 is 12. And again, either on paper or in our minds, everything else remains unchanged. Now there's only one operation left. We're subtracting two signed numbers. And remember that subtraction in algebra means add the opposite of what follows. Now we're adding unlike sign numbers. So we take the difference, which is 6. This one has the greater absolute value, so we give it its sign. So there we have it. Let's pause now to make a special note of those situations where all operations are multiplications or divisions. Now, we know the answer will be plus or minus, so let's determine that first. So minus times minus is plus, plus times minus is minus, minus times minus is plus, plus times negative is negative. Same thing down here. Negative times positive is negative, times negative is positive, positive times negative is negative, negative times positive is positive. Now also note this. In my string of multiplications, if I count the number of negative multipliers, 1, 2, 3, 4, 5, it was negative. And that's an odd number, 5. But here I have 1, 2, 3, 4, not counting that. I had an even number of negatives, and my answer was positive. Now if you think about that a moment, that's very reasonable, because every time I multiply two negatives, it becomes positive. So if I have an even number, I will have nothing but positives being multiplied. But if there's an odd number, for every two of them, which is what we mean by even, I get a positive product. So being an odd number, there's always one negative left over. That's what we mean by being an odd number. If you divide by 2, there's 1 left over. And that times the positive product before it is always negative. So we can shortcut our continuous multiplication and think this. When there's an odd number of negative multipliers, the answer was negative. When there was an even number of negative multipliers, the answer was positive. Now, once we've determined the multipliers, we can simply multiply the absolute values. So 2, 6 times 5 is 30. So my answer here is negative 30. Down here, There's 10 times 10 is 100 times 8 is 800. So again, a shortcut. If you're multiplying an odd number of negatives, the answer is negative. If you're multiplying an even number of negatives, the answer is always positive. And that allows you to forget the signs once you determine the sign of the answer and concentrate on the absolute values. One more special note. If we write something like this, do we mean 5 being squared and that opposited? That is this, 5 squared, that being opposited, or do we mean a negative 5 being squared? See, that can be very confusing. So we're going to have a special definition. If there is no parentheses and you have both a dash and an exponent, we will presume that the exponent is always done first. That would be 25, and that opposite, which would give me negative 25. Whereas if we meant I want to square a negative 5, that is, I want a negative 5 times a negative 5, which in this case is positive 25. We'll use parentheses to indicate that. So please note, exponents are always done before opposites, that this is oppositing not 5, but the results of 5 being squared. If I do want to square negative 5, I will use parentheses to note that. That is an accepted mathematical convention. Now let's emphasize that through these two simple problems. This says I want to take 29 negative 1s and multiply them together. So this is a negative 1 being raised to a power. Now we know that 1 times 1 times 1, etc., 29 times is going to give me a 1. Same thing in this case. If I take 300 1s and multiply them together, it still is 1. Our critical question, is it positive or negative? Now note, this gives me an odd number of negatives being multiplied, and our shortcut said that will always be negative. This is an even number of negatives being multiplied, and our shortcut said that's always positive. So this really emphasizes the facts that an odd number of negatives being multiplied is negative. An even number of negatives being multiplied is always positive. Now, back to our main theme of order of operations. Again, when you see an expression, see first the operations. Then ask yourself, of those 4 operations, which do you do first by the order of operations? Minus, plus, exponent, times. And then recall that your exponents are done before you do the 4 basic operations. So I do the squaring, which now is over the entirety of negative 3. So negative 3 times negative 3 is positive 9. And in my mind or on paper, I leave everything else alone. And then of the remaining operations, I ask, what do I do first? And again, multiplication is done before subtractions or additions. So the multiplication is between these two. So I'm multiplying 2 positives. The answer is positive. 9 times 2 is 18. And again, everything else remains mentally unchanged. And again, I ask, of the remaining operations, which is done first? And of course, if you have only subtractions and additions first, you do them as you come to it. So I'll do this first. But now remember that subtraction means add the opposite of what follows. And that, of course, is negative 2 plus 18. And by now we know that that is plus 16, and I'm done. So again, concentrate totally on operations. The numbers are only secondary to this. Now, the order of operations are most important in evaluating formulas, which many people do, whether they take algebra or not. Let's take the case where we know that the temperature is minus 10 degrees or negative 10 degrees Celsius, and we wish to convert it to its equivalent Fahrenheit degrees. So we find a formula. Now this tells me my C, which stands for the Celsius degrees, will be replaced by minus 10. So my formula becomes F equals 9/5 times C, which now is negative 10, plus 32. But see, we have several operations there. So the question is, which ones do we do first? And of course, multiplication is done before addition, not because it came first, because that's the order of operation. If this is written second, I'd still do that first. So notice I'm going to multiply a positive fraction times a negative number. Positive times negative is negative. And we have 9/5. Now just hold that in my mind. Times 10. Using the cancellation law, we get 18, but we decide ahead of time it was negative 18. So this arithmetic here was negative 18, and what's left is plus 32, and that's going to be my Fahrenheit degrees. Now we're adding unlike signs, so we take the difference, which is 14, give it the sign of the larger absolute value, which is 32, and that's positive. So 10 degrees minus 10 degrees Celsius is the same thing as 14 degrees above zero, or plus 14 degrees Fahrenheit. Very, very frequently in formulas you have to use negative numbers and then the order of operations. Let's continue by working one problem which, although short, has basically one of all of the major operations. Let's emphasize several points about approaching algebra and learning itself through this problem. And that is, first in algebra, when you have an expression, be it an expression or an equation. Now note, do you know the difference between an expression and an equation? An expression in mathematics, in algebra specifically, is a grouping of symbols which ultimately can be replaced by a single number. An equation, on the other hand, is an statement about two expressions. This stands for one number, this stands for one number, this says I want those two numbers to be equal. So an equality is two expressions wanting to be equal. An expression is simply a group of symbols that ultimately stands for one number. Well, whether you're looking at an equation, and we'll do this one next, or an expression, evaluating it, which means finding that one number it's equal to, in both situations you don't look at the constants, nor in the equations the variable. You look first and always at the operations, because it's the symbol that's telling you what to do and what to do it to. So always note first the operations. Then if it's a matter of evaluation, your mind thinks immediately order of operations. Please note, the problem doesn't tell you the order of operation. It's just asking, do you know it? And if you can, then use it to solve this problem. Many students believe that the problem is what's teaching you. The problem is not. The problem is what's checking whether you have learned. So to use the order of operations, without even looking at the problem, because it has nothing to do with it, can you tell somebody on the telephone what's the order that you would do all of those operations, or any series of operations? And hopefully you would say, well, first I will evaluate the insides of parentheses. Then next I will do the exponents. Then third, I will do the multiplications and or divisions. And the reason we say and or is I do whichever of these comes first. If this comes first, I do it first. If this comes first, I do it first. Then finally, the additions and or subtraction. And again, the and or means whichever of these I come upon first, reading from left to right, that's what I will do first. So this should be at the back of our mind, not even in our notes, but on the back of our minds, guiding us through this problem. So the first thing we do is look for parentheses. There's one there. Now we'll stay there until it's one single number. So everything else stays the same, including the exponent of the parentheses. Now inside the parentheses, I look for more. There aren't any. Now I look for exponents inside the parentheses. There aren't any. I'm not to this yet. Then I look for multiplications and or divisions. That's not one. That one is. So is that. But I came to this first. So 18, not negative 18, because this is not a negative, it's a subtract. 18 divided by 6 is 3. Then I look for more. There it is. So 3 times 2 is 6. So doing the multiplications and or divisions before the subtractions, I have now reduced the parentheses to 4 subtract 6. Subtraction, if you need still to think of it as add the opposite, do so. So 4 added to negative 6 is negative 2. So we have done inside the parentheses until it's evaluated to a single constant. Now back to our order of operation, we look for exponents. Okay, again, always concentrating on operations and not numbers nor their signs, just operations. So the 3 remaining operations, that is an exponent. It's above negative 2, so negative 2 times negative 2 is positive 4. Everything else in my mind or on paper stays the same. Now I look for more multiplications and or divisions. There aren't any. Additions and or subtractions as I come to them. So I come to this first. Negative 5 minus 8 is, now if it helps you think this way, do so. Now you can clearly see it's negative 13 being added to 4, and adding these I get negative 9. Clear? Let's make it very, very clear. This information now should be a part of your thinking. Should not have to use notes anymore. One more just to raise a special point. Here, identifying the operations first, we have subtraction, addition, subtraction, addition, subtraction. Realize because of the special nature of subtraction, that subtraction really means opposite, add the opposite of what's following. In a sense, you can get around all the subtractions. So I could go through a problem with additions and subtractions, and every time I see an addition, a subtraction, change it to add the opposite of what follows. Add the opposite of what follows. Add the opposite of what follows. Now just go through and concentrate on addition alone. And in addition, I'll find all the like signs first. So there's a negative, there's a negative, there's a negative, there's a negative, there's a negative. So I know the sum of negatives will be negative. So I concentrate on their absolute values. 2, 9, 14, 17, 25. And in this case, there's only one positive left. So now only once do we have to add unlike signs, which is going to be negative 17. So in more advanced algebra, you will routinely just go down the line and get rid of subtractions. Now let's conclude this unit of study with solving an equation in which there is not just subtraction or addition or just multiplication or division, but where they're mixed. Remember our objective by using the rules of equations, which says I may add the same thing to both sides, subtract the same quantity from both sides, or divide or multiply both sides by the same quantity. But by maneuvering our numbers around by using those four laws, we want to eventually get this in the form of 1 times x. It's as though we want to peel these away from the x and get to 1x. Interestingly enough, whereas in the order of operations, when we're evaluating an expression, we do the multiplications and or divisions first, then the additions and subtractions. As we try to begin to isolate the variable, interestingly enough, we go just the reverse. We undo the adding or subtracting first. Do you have that? Undo the adding or subtracting first. Then the multiplications and or divisions last. So if I want to undo this subtraction, I do so by adding 5 to both sides. So plus 5, subtract 5 is 0, leaving just this quantity, which is 3/4 times the variable x. And adding 5 to negative 7 is negative 2. Now we want to undo this multiplication, but thinking more specifically, we want it to be 1 times x rather than 3/4 times x, and recalling our reciprocal law, that says 4/3 times 3/4 gives me 1 times x, and the multiplication law of equality says I must multiply the other side by the same amount, and this gives me negative 8/3. And again, in algebra, we will prefer this form to negative 2 and 2/3. But of course, they both stand for the same number, so logically one is as good as the other. Again, note, we undid the subtraction, then we undid the multiplication, and we undid the multiplication by multiplying both sides by the reciprocal of that which I wanted to be transformed into 1. One more, and also to emphasize, there's nothing saying the variable has to be on the left. It could just as well be on the right. Now note, I want to undo adding 5 to 2/3 p by subtracting 5, or if you wish, adding the opposite. Because 5 plus negative 5 is 0, and that's undoing. But then I have to add the same thing to the other side. So this plus this is 0, leaving me with 2/3 times p. And this side becomes negative 14. Now we wish to undo this multiplication. So we multiply both sides by the reciprocal of that fraction, enclosing this one in parentheses so I don't mistake that for a subtraction because it is a negative number. This gives me 1p by the reciprocal law of fractions. So my game has been won. I have this side transformed to 1 times p. It's simply a matter of doing the arithmetic on this side, but note, I can cancel here. 2 goes into here twice, 2 goes into here negative 7. 3 times negative 7 is negative 21 over 2, or if you wish, negative 21 halves, or if you wish, negative 10 and 1/2. But again note, I undid the addition first, then I undid the multiplication. And of course, the main chore of this lesson, evaluating expressions through the order of operations. Let me conclude by working this rather rapidly to show you how fast you should be doing it with very little practice. First, get inside the larger parentheses, here indicated by brackets, then inside of more parentheses. Inside of here, I do the multiplication before subtraction, so that gives me 10 minus 7 is 3. Staying inside the brackets, I now look for exponents, so there is a 3 squared, so this part here becomes 9. Rewriting everything over now. Now inside, looking for more exponents. There aren't any. Back to the beginning, look for multiplications and or divisions. So this one, so that gives me 18. Skip the subtraction because I see a division coming on, and that's to be done first. So 8 divided by 2 is 4. And 4 times 3 is 12. Then 18 minus 12, obviously in this case, is 6 squared, and finally 36. I have moved right along there rather rapidly, but in fact with very little practice, as a good student in algebra, you should be going perhaps 2 or 3 times faster than I did here. In fact, much of this work that I've shown on paper, you will and should do in your mind. We have to show you as teachers on paper because, of course, you can't see what's in our minds, but try more and more to hold your work in your mind as you move along. So this will conclude your last lesson in this unit. I hope you will find that it will be of great assistance in your beginning of Algebra Proper as your next course. This is your host, Bob Fennell, saying good luck.